Now let us see one more problem, that is form a partial differential equation by eliminating the arbitrary constants. The arbitrary constants a and b from this equation x minus a the whole square plus y minus b the whole square is equal to z square cot square alpha. So here a is an arbitrary constant, also b is an arbitrary constant, but this alpha is not an arbitrary constant. So you don't need to eliminate this alpha because this is a fixed constant. It will be mentioned in your question paper, that is a and eliminate a and b only. Now here number of independent variable is 2 and the number of arbitrary constant is 2. Therefore, we can use only the first order derivatives. So that is differentiate. You take this is equation number 1, differentiate 1 partially with respect to x. So your answer is x minus a the whole square. This is of the form x square. X square differentiation is 2x. So 2 into x minus a. This term contains no x term, so it is constant 0 equal to z square, that is 2z, and z differentiation is dou z by dou x. So whenever differentiate with respect to x, you should apply the differentiation for z, and this cot square alpha is a constant, keep the same. So now dividing by 2, x minus a equal to z into what is dou z by dou x, that is p cot square alpha. Now you take this is equation number 2. Once again we differentiate the equation number 1 with respect to y. So differentiate equation number 1 partially with respect to y. What is the differentiation? The same way, 2 into y minus b, because x is 0, x is a constant, its differentiation is 0, equal to 2 into z dou z by dou y cot square alpha. Dividing by 2, your answer is y minus b is equal to z into q cot square alpha. So if the equation contains bracket, you try to find the inside value, bracket inside value. So here x minus a, that is the inside value, here y minus b inside value, then we can substitute this x minus a and y minus b in the given equation. So you take this is equation number 3. Equation number 3 using 2 and 3 in 1. Using 2 and 3 in equation number 1, what will be the answer? That is z p cot square alpha the whole square plus zq cot square alpha the whole square equal to z square cot square alpha. So that what is answer? That is z square p square cot raised to 4 alpha plus z square q square cot raised to alpha 4 alpha equal to z square cot square alpha. Now you dividing by z square cot square alpha. So that is equal to p square cot square alpha plus q square cot square alpha equal to 1. So here you note dividing by z square cot square alpha. Okay. Okay. So what is the answer? That is p square plus q square into cot square alpha is equal to 1. You take this cot square alpha to RHS side, that is p square plus q square is equal to 1 by cot square alpha, that is equal to tan square alpha. So this is our required answer. So final answer is p square plus q square is equal to tan square alpha. This equation contains no arbitrary constant. So this is our required